Most people know mitochondria as the powerhouse of the cell, but what if that powerhouse holds the key to preventing the diseases we fear most? Alzheimer's, Parkinson's, and the fog and fatigue so many are still fighting after COVID. This is Vital Signs, where we sit down with leading voices in health and medicine to separate real science from noise. Today's guest spent 26 years practicing neurosurgery, where he used targeted nutrients to help protect patients' brains after surgery, an approach many considered ahead of its time. Since then, he's built a body of research connecting inflammation, brain energy, and brain disease. Welcome to Vital Signs. I'm Brendon Fallon. Dr. Blaylock, such a pleasure to have you join us on Vital Signs again.
Thank you. I appreciate it.
To start with, I want to ask, why are we hearing so much about mitochondria these days? It seems recently it's become the topic of mitochondria has become really central to discussions around preventing chronic disease. Why is that?
Well, for too long, it was ignored. People just assumed, well, it made cell energy and nothing else. And sort of the researchers on mitochondria were separated from the clinical physicians like neurologists and neurosurgeons and neuroscientists. And eventually they realized, well, the mitochondrion is doing a lot more than just providing the cell energy. And we all knew that if the cell doesn't get energy, it dies, but we didn't know exactly why it died. And now we realize the mitochondria controls that death. We call it apoptosis and necrosis. So then we realized, well, it's also controlling calcium. Calcium is the number one agent inside of the cell that goes through cell signaling. So it is very important. An excess of calcium causes cancer, the cell to become dysfunctional and eventually die. Well, then we realized that, well, most of the
Hello, Dr. Blaylock, can you hear me? Dr. Blaylock, I think we just lost you there for a second. Can you hear me okay?
Yeah, it went black for a while.
Okay, I think we're back anyway. So do you want to just continue where you left off? You were talking about the apoptosis and necrosis, how the mitochondria is controlling the death of the cell, if I understand.
Right, it's doing a lot more. It's controlling the number one regulator of cell signaling, which is calcium. And if calcium accumulates, it produces a triggering of cell death and cell malfunction. And then we found, well, the mitochondrion in the brain and nervous system, because the nervous system has these long connecting nerves like axons and dendrites and synapses, well, the mitochondria actually migrates. So it goes from the cell body down the axon all the way to the synapse and supplies it with all of these various factors that it needs. If it can't travel, if it cannot get to the synapse, then the synapse malfunctions. And we see in diseases like Alzheimer's is mainly a defect in synapses. That's the first defect we see. And we start looking
at the synapse, if I understand, this is the gap between the neurons where the exchange of chemical signals takes place. This is where I guess the communication happens between neurons, you might say.
Yeah, if they can't communicate, then things kind of go haywire. And the communication of the synapse is very complex, but it requires a tremendous amount of energy. And it requires control of the calcium. We find that if neurons have too much calcium in their cytoplasm outside of the mitochondrion, it becomes dysfunctional. And a lot of these diseases are caused by accumulation of calcium. So all of these things kind of connect together, and we begin to see, well, actually the mitochondrion is playing a large role in the pathophysiology of all these neurodegenerative diseases. ALS, Alzheimer's, Parkinson's, frontopolar degeneration, dementia, a great thing, trauma, strokes, it's playing a major role. And if you can get the mitochondrion back functioning properly, then you can improve these conditions tremendously. But it's very easy for them to be damaged.
And that's what we're going to be talking about today, because you've provided a very extensive list of specific nutrients that can be beneficial to improving mitochondrial function. And I'll read through those a little bit later in this interview and get your further input on those. You've mentioned a number of diseases that are related to this dysfunction of mitochondria. Are these what would be described as mitochondrial diseases, or is a mitochondrial disease something beyond that?
Well, it's intimately connected with it. And what we see in all of these diseases, there's a large pathophysiological play by the mitochondrion. It's not acting just in strictly mitochondrial diseases, like Mela's. Now, Mela's is a defect in the mitochondria you're born with, and it develops all kinds of neurological stroke-like syndromes and encephalitis. And then we see other mitochondrial diseases. But these mitochondrial diseases are pretty obvious, and a lot of them are fatal. They don't live very long. And recently we found that there's a lot of different ways to enhance the function of those mitochondria so these serious diseases can live. But what we found, for instance, particularly in autism, was that a lot of these children have subclinical abnormalities of their mitochondria. That is,
what does that mean, Dr. Blaylock, subclinical?
Well, you don't really know it. And what we find with a lot of things is as long as you're just sedentary or not engaged in physical activity, your mitochondria is doing just fine. But if it's stressed, that is, you're engaged in heavy physical activities, sports, and a job that's very physical, you experience a lot of symptoms like fatigue, difficulty thinking. You can have localized mitochondrial problems that you can inherit, and you have difficulty with the visual nerves in the eye working, and then they'll gradually go blind. So we see that it's playing a big role in a lot of diseases we don't know. And a lot of these mitochondrial defects that are subclinical are not diagnosed. So you have a child who's doing just fine, he seems okay, but then when he gets a stress injected in him, like a vaccine, the mitochondrion suddenly fails. And all sorts of things begin to fail, like his calcium begins to elevate inside of the cell. And so all sorts of problems can occur. Cell doesn't get enough energy, and that makes glutamate more toxic, excitotoxicity. So the effects of the mitochondrial failure is enormous. And we're beginning to appreciate that this is playing a big role in all these diseases. And if you look at all these neurodegenerative diseases, we see where the mitochondria is playing a major role in these diseases. And there's just...
And I imagine Alzheimer's would be at the center of those, which is largely the focus of what we're going to be talking about. Interesting what you were saying about when the body is put under more strain, when it has to perform like more physical exercise, when it's under more physical strain. I wonder, what about in terms of mentally straining activities? Because I know the brain must be using a lot of energy to achieve different tasks, and where work is more intellectually challenging, is this also putting a strain on mitochondria? Would this produce visible effects if someone is under strain from using their brain excessively?
Yeah, we have certain tissues like the brain, the heart, the muscles that use a lot of mitochondrial energy production. And when the brain, it doesn't do like a muscle, it's not contracting and lifting, it thinks. And what we find, people have mitochondrial defects in their brain, they have brain fog, they have difficulty concentrating, they have mental fatigue very easily, they can't concentrate very long because it requires a continuous supply of energy, control of the calcium, and these other processes in the mitochondria in order to carry that out. So if you have a person that's intellectually very busy doing a lot of things, mathematics and history and learning things, their mitochondria in their brain is intensely active, more so than a person who doesn't read, doesn't think, doesn't engage in a lot of mental activity. So you're right. It's kind of a corollary of the muscle. The muscle's doing physical exercise, the brain's doing intellectual exercise, and they're both consuming enormous amounts of energy.
There's a question I wanted to ask you. It's on a bit of a tangent, and I know that there was some studies, or at least one study I'm aware of, in terms of long COVID, where they were testing nicotine, using nicotine patches, and some patients showed an improvement with long COVID symptoms using nicotine patches. Not extensively studied. This was quite a small study that was done. And I noted that you've written about the compound nicotinamide as something that can improve mitochondrial function. I know there's a chemical relationship between nicotine and nicotinamide, but I wonder, is there some connection between nicotine producing these effects for long COVID patients and the potential for nicotinamide to help someone with, say, a mitochondrial dysfunction?
Well, it has some role, but if you look at nicotine stimulates cells in the brain called nicotine acetylcholine type receptors. And their function is, if there's too much immune reactivity, too much inflammation in the brain, it calms it down. If we look at long COVID, what happens is these people have a continuous generation of their immune effect, so that their brain, the rest of their body, is flooded with these immune chemicals, mainly chemokines and cytokines, that's producing inflammation. They're constantly inflamed. So when you give nicotine stimulates that system in the brain, the nicotinic acetylcholine, and it calms it all down, and they feel a lot better. They can think a lot better. But it's not a mitochondrial effect directly. It's sort of an indirect effect.
So it's having an effect on reducing the inflammation in the brain, the nicotine.
Yeah, when you look at all these neurological diseases, and a lot of diseases in general, they're all inflammatory. And what you see with long COVID or any of the COVID vaccines and stuff is you see a low-grade chronic inflammation. Well, the most damaging of all is low-grade chronic inflammation. And you'll see patients that they don't know they're inflamed. If you have an inflamed joint in your wrist or knee, you pretty well know it, but they don't know it. And so you can have inflammation in the brain and you're not aware of it, but you just can't think straight. You fatigue easily. You have brain fog. And if you clear up that inflammation, get rid of it, that goes away. We're intimately connected to the inflammation is free radical generation. And if you look at cytotoxicity, all the pathology of Alzheimer's and Parkinson's and ALS, they're all produced by high levels of free radical generation, producing damage. Well, what's causing the free radical generation? Inflammation. And so they're intimately connected. And if you look at cytotoxicity, its main effect is by increasing free radical generation. Same thing that inflammation is doing. So inflammation and excitotoxicity, these other things are intimately connected. They're all producing the pathology that you're talking about.
I think you've answered my next question to some degree, Dr. Blaylock. It's in relation to the obvious symptoms that are seen with Alzheimer's disease. Things like some of the things we've been talking about, like the brain fog, the loss of cognition, loss of neurons, loss of synapses. Is there a direct connection between these things and the dysfunction of mitochondria?
A very strong connection. And what we see is The mitochondrial defect occurs in these cells in the brain long before we see any of this beta amyloid or tau hyperphosphorylation, which unfortunately, the researchers thought the disease is caused by these things accumulating. They thought, well, it's beta amyloid is causing the disease and it's accumulating in the brain. And then hyperphosphorylated tau is causing the problems in the brain. And the researchers showed, well, the brain is undergoing its functional problems before any of those even appear. And it seems to be—
How long would you say the onset before those things, these very common symptoms, you might call them, the proteins you mentioned, and the tau particles, how long does Alzheimer's start, would you say, before these things start to show up?
Oh, years before, even decades.
Wow.
And so what we know in neurology and neuroscience is that you can lose about 50% of neurons in a particular nucleus before anything happens, before you notice it, before there's any dysfunction. So you've already lost a lot of your neurons before you're even aware of it. The symptoms that we see, like the onset of Parkinson's and Alzheimer's, is when you're losing the last few. And then they become non-functional. And what we're finding is a lot of these neurons aren't dead, they're just not functioning right anymore. We call it a physiological effect. And one of the things we used to say, for instance, was a neuropraxia. And that's if you compress a nerve, it quits functioning. And we used to talk about the Saturday night people who get drunk and they drape their arm behind their chair and they compress their nerve. And then they can't move it. Their arm won't move. And you wait 20, 30 minutes and it all comes back. Well, that's a physiological disruption. It's not like a physical disruption where it doesn't come back. And that's what's happening in a lot of neurological diseases, is that we have physiological disruption. And we find some of the cytokines, like tumor necrosis factor alpha, can do it for decades. There's a researcher friend of mine out in California who took patients who had strokes 10 years before, and they were serious strokes. Couldn't walk, they couldn't move an arm or leg. And he gave them an injection of a blocker of tumor necrosis factor alpha inside the spinal canal in the fluid. And they almost returned to normal. They could move their arm again, walk again, think again. He tried it on Alzheimer's patients and they got better. Not completely well, but they got a lot better. Well, there's a lot of cytokines that do that beside tumor necrosis factor alpha. And like interleukin 1 beta does it, interleukin 6, interleukin 18. So we've kind of found a headway that these are interfering with the function of those neurons, but they haven't killed them. They're just not functioning anymore. And so we can see a lot of this occurring long before the disease becomes full blown. So that many of them die, say 50% of them die, and then another 20% are just non-functional. And then the person will develop all of the symptoms of Alzheimer's or Parkinson's, and it becomes quite clinically evident. But if you can treat it properly, these neurons start working again, and the symptoms go away. Well, we even found it in children. I mean, we found it soon after birth. You can damage a good number of the neurons that are responsible for Parkinson's disease when they're children, babies. And they lose the last few when they're adults by exposure to chemicals like pesticides, herbicides can cause them to disappear.
It's a hopeful message. I would say that these neurons are still there, they're just not functioning, and there's the scope to bring them back and potential recovery that would come from that. I think I may have interrupted you earlier in answering that question, Dr. Blaylock, talking about how the mitochondrial dysfunction would connect to these obvious symptoms like the loss of neurons, the loss of synapses, the brain fog. Is there more that you'd want to add to that?
Well, we're seeing that in more diseases that we thought were incurable. For instance, some cases of Parkinson's disease, you look at them and they look terminal. I mean, they look like you're at the end of the course. They're spastic, they can hardly walk, they're bound to their bed. And then you give these blockers and block these agents, then you see them return almost to normal. And so you suddenly realize, well, this disease wasn't at its end point, just you wasn't doing the right thing to stop it from eventually killing those cells. And if you keep interference with the mitochondrion or these other cell signaling apparatus like calcium control and excitotoxicity, it will kill the cell. The cell will kill itself. It's like I say, all cells have an apoptosis system, that is a suicide system. It's controlled by the mitochondria. Many of these agents that I listed for you, what they do is they stop apoptosis, so the cell won't die. And they correct a lot of the defects of the mitochondria, so it's working better. One of the things is like mental fatigue or physical fatigue, and you get older. Well, we find that mitochondria age also. Well, the mitochondria is not dead, it's just not functioning correctly. And if you give this agent, suddenly the mitochondria starts working right, the energy returns, both mental as physical, the heart starts beating better because there's a lot of mitochondria in the heart. And if you age and are exposed to chemicals or a poor diet, suddenly the mitochondria is not working well and your heart doesn't work well. You develop all these heart failure, arrhythmias, even a heart attack. So if you can get the mitochondria in the heart to start working right, you can reverse that. So now the heart is no longer enlarged, it's starting to pump blood like it's supposed to, which has an effect on all your organs, including your brain. So your kidney, your liver, your intestines, everything works better because now your circulation's improved, because you improve the mitochondrial function in the heart.
This is very interesting to hear, and not something that's really, I think, very much in the public sphere. How much mitochondria factor into these different diseases, and also why mitochondria might be impacted, including with the impact of pesticides that you've touched on a little bit there, Dr. Blaylock. So having heard this, I'm interested to know, what does the research indicate about how optimizing mitochondria could prevent neurodegeneration?
Well, it not only prevents it, but it reverses it. And that's because now it's starting to control calcium supply. It's starting to provide efficient energy. As the energy rises, there's less excitotoxicity. There's a reduction in the secretion of glutamate, which is an excitotoxin, from two cells in the brain, the microglia and the astrocyte. It all gets very complex. I mean, it's complex anatomy and it's complex chemistry inside of the brain. Neurochemistry is a very complex field of study. But as you begin to look at this, a lot of these diseases that we treated as just something pathological happens, we're now finding where there's a lot of biochemical events going on long before they present. And so, you were asking how long. Well, it's going to be a lifetime. And if you do something early in life, like exposure to pesticides, or you're exposed to vaccines as a child, you can kill a lot of cells in these different nuclei, like the substantia nigra that causes Parkinson's disease or connected to Parkinson's disease. You can lose a lot of those neurons when you're a small child. Well, you won't know it then. But when you reach middle age and those nerve cells start to age, the mitochondria start to age, they don't function as well, then you're starting to lose the last 20%, 30% of those cells. It's not that they're dead, they're just not functioning right. And so all these symptoms appear. And so you go to your doctor, and your doctor says, well, they're gone and they're not going to return. It's just learn to live with it. Here's a wheelchair, and here's we're going to treat some symptoms. Well, the idea now is, well, we're not treating symptoms, we're trying to stop the process. And they're having a fair results in stopping the process.
I wonder on that front, Dr. Blaylock, do you have any examples? I mean, I know for one, you could probably draw from your experience as a neurosurgeon using nutrients in that context. Apart from that, or including that, do you have examples of where someone has shown reversal or recovery from potential neurodegeneration through optimizing, taking these kinds of measures?
Right. Well, we see a lot, for instance, like with the Miller syndrome, which is a very serious damage to the mitochondria that's inherited. When they use some of these agents that I listed in that group, they could live a normal life or a lot better. And when we see people with subclinical mitochondrial defects, suddenly they can start exercising and engaging in sports and doing things they couldn't do before. People with mental fatigue find, well, the mental fatigue has now disappeared. I can concentrate, work long hours that I couldn't do before because I fatigued so easily. Well, that meant your neuron was running out of energy and couldn't supply the energy, couldn't control these other neurochemical processes. Now you could, because I just replaced a few things that corrected the defect. And what we're seeing is that a lot of these changes in the mitochondria are correctable. We now have agents, particularly plant extract, that can correct a lot of these things. And we can measure them. For instance, one of the real protectants of a cell is glutathione. And we find several of these supplements can raise the level of glutathione. We see, for instance, the first defect we found in an electron transport system was with Parkinson's disease. And they found out, well, the earliest change in Parkinson's disease, even before they developed symptoms, was they had a defect in complex 1. It's usually 5 complexes that you go through in the electron transport system to produce the ATP, which is your energy for everything. And so they had a defect in complex 1, and that was making this neuron not work or work very poorly. And if you corrected that, and several of these supplements will correct complex 1, like CoQ10 in high doses corrects complex 1. And methylene blue corrects complex 4, which is seen in Alzheimer's disease. So it's changing the whole aspect of our treatment of disease from just treating symptoms. Well, now we're treating the pathophysiology. What caused it in the first place? What's defective? What is missing? What did we lose a long time ago that we can regain? And that's what we're finding in the field of plant extracts, as these extracts can do it when drugs can't. Drugs just treat symptoms. And a lot of people, they don't work. And eventually they stop working. But the long-term effect of these supplements can last a lifetime.
Well, that is a terrific introduction to running off this list that you've provided, Dr. Blaylock, of supplements. Before that, I just want to add as a caveat that these supplements that you provided, they have Dr. Blaylock has provided, has the potential to improve mitochondrial function with some general dosage information also provided here. There are no specific safety concerns for most of these, but even so, this info is not to be taken as a prescription, and you should always consult your doctor or other healthcare provider before trying new treatments, even supplements, particularly because while these supplements may be generally safe, there's the potential for them to react with medications or even other supplements you may be taking to bad effect. You may also have specific health conditions that may make you more susceptible to the effects of certain supplements. So please seek personal health advice before changing your treatment plan. With that said, I'm now going to run through the list of supplements for improving mitochondrial function that Dr. Blaylock has provided. You can also find this list included in the description below, alongside some specific safety information for a few of the supplements mentioned. And here is that list. So, Dr. Blaylock, I invite you to interrupt me at any point if there's anything you want to add to in terms of these, to add to the description of these supplements. So first one, nanoresveratrol, also known as pterostilbene, take 1 capsule with each meal. Nanocurcumin, dose recommended is 1 250 or 500 milligram capsule 30 minutes before each meal.
Yeah,
Nanoquercetin.
Well, the reason I give or take it 30 minutes before is it takes 30 minutes for you to absorb a capsule if you're sitting up or out of bed. If you're laying in bed on your left side, it takes about 15 minutes. So you're taking it before, and what I give that caveat for is that curcumin can steal some of your iron. And some people have gotten iron deficient. Well, it's stealing it from your food. So if you're absorbing the curcumin before you eat your food, then it doesn't do that. Most of these supplements, just to add this commentary, have been extensively tested. Curcumin has been tested in extremely high doses, found to be non-toxic, even taking it for a long period of time. And as maybe one other time we mentioned, iron accumulates as you age. And iron is very closely connected to cancer. It's very closely connected to neurodegeneration, all diseases. Men tend to accumulate a lot of iron. Women tend to accumulate it after they reach menopause. And women will accumulate faster than men after menopause. And it causes severe degeneration of the brain and the nervous system. So the fact that the curcumin is removing some of the iron is not a bad thing. It's just you want to control it. You may want to, after a couple of weeks, get an iron level and make sure it's okay. But just do that. Take it 30 minutes before, so you've absorbed it before you eat your meal.
Okay, and so that was nanocurcumin you were just discussing, Dr. Blaylock. Nanoquercetin, a recommended dose 250 milligrams 30 minutes before a meal. And this can cause hypoglycemia, low blood sugar, if taken on an empty stomach. You've talked about this a number of times before, but I would just invite you to explain why nano compounds are particularly recommended for the ones we've just mentioned there.
Well, what they realized is that curcumin had tremendous effect if it was injected, and quercetin had unbelievable effect if it was injected. People have trouble absorbing it, particularly like curcumin in treatment of pancreatic cancer. Well, they found if you fed large doses to pancreatic cancer patients, it had very little effect, where they weren't absorbing very much. So they nanosized it, which actually just makes the molecule real small and highly absorbable. Then there was tremendous effect on the pancreatic cancer. And they found out not only is it well absorbed from the GI tract, but it passes into the brain very easily, passes through the blood-brain barrier, and passes through the cell membrane, enters the cell, gets all the way to the nucleus. So you get excellent biodistribution, more than just absorption from the GI tract. But we see that in a lot of these chemicals that I name use nano products, like the nanoresveratrol. It's the same thing. It's very poorly absorbed. But once it's nano, it's extremely well absorbed and distributed throughout the body, including the brain. And it's very safe. They tested the safety of each of these nano products, and they're extremely safe.
Excellent. Now moving on, another one quite commonly known, melatonin, the hormone associated with sleep, 1 milligram at bedtime, and 1 milligram each time you may wake up. Could you explain that a little bit, Dr. Blaylock? You mean if someone is waking up, oh, if they're waking up during the night, then they might take another milligram.
Right. This is very common in the aged, is they wake up at 2 or 3 o'clock in the morning and can't get back to sleep. Well, you just take another melatonin and go right back to sleep. Melatonin is an incredible chemical. It's very powerful anti-cancer chemical. It's a very powerful protectant of the mitochondria and mitochondrial function. So it's undergoing a lot of research looking at melatonin and how protective it is. So we see why your brain secretes it every day. It's just doing more than just helping you sleep.
Yes, a master antioxidant, as I've heard it described before. Vitamin E mixed tocotrienol.
Tocotrienol.
Tocotrienol. Is that a specific form of vitamin E?
Yeah, vitamin E is really a mixture. There's 4 types of vitamin E, tocopherol, and then there's 4 types of tocotrienol. So together there's 8 different forms in most vitamin E. And they found that the most powerful in protecting the brain and the rest of the body is tocotrienol. So rather than taking the vitamin E, just take tocotrienol.
And you've indicated a general dose of 100 milligrams, 2 caplets twice a day. Carotenoids, lycopene 20 milligrams a day. Riboflavin 5-phosphate 50 milligrams a day to 50 milligrams 3 times a day. Benfotiamine, vitamin B1, which is vitamin B1 thiamine, 300 milligrams a day. Pyridoxal 5-phosphate, 10 milligrams a day. Vitamin C, 500 3 times a day between meals. Nano ginkgo biloba, 1 capsule a day. Do not take with any anticoagulants. Spermidine, 10 milligram capsule twice a day. Nicotinamide, which we were discussing before briefly, 100 milligrams twice a day. Acetyl L-carnitine, 500 milligram capsules 2 a day. Astaxanthin, one of the most powerful antioxidants, 1 12 milligram capsule twice a day. This is one associated with the more colorful vegetables and fruits, if I remember. Is that right?
Right. Especially the red ones, like red cabbage and things like that. But it's been shown to be the most powerful antioxidant we know of.
Yeah, I've heard this one come up a number of times. Also, this one, bicalin or bicalin, if I'm saying that correctly, which has a powerful anti-cancer effect. We've spoken about that in terms of cancer prevention before. And you've said 1 500 milligram capsule 3 times a day. Hesperidin, 1 500 milligram capsule twice a day. R-lipoic acid, 50 milligrams after the dose of acetyl L-carnitine, take with a meal. If I'm not mistaken, you can get a certain variety of cooking oil or oil you might add to food that would contain lipoic acid. Is that correct?
Well, the warning I have about R-lipoic acid, lipoic acid has 2 isomers. One is the R and one is the S. The most effective is the R. And so when you get alpha lipoic acid, it's a mixture of the 2. It's not as effective. When you get the R-lipoic acid, it's highly effective. The problem with lipoic acid for some people is it's very hypoglycemic. And so you want to take it just before a meal, and then it doesn't bother you. But I've used R-lipoic acid in a patient who came in with an aneurysm and was in a coma. And I gave an intravenous dose of R-lipoic acid. The person woke right up. So it's pretty good. And they did it in Chernobyl when radioactive isotopes went all over Kiev. And they had a lot of people with real high changes of radiation in their body. Well, they fed them R-lipoic acid and it returned to normal. So it's very highly protective antioxidant, and it increases complex 1 in the electron transport train.
And the electron transport train, this is part of the energy production process. Is that correct?
Yeah, it's the main. We call it oxidative phosphorylation, and it goes down this chain from complex 1 to complex 5, and then it's converted to the energy molecule ATP.
Right. So they're essential to metabolism. Going on, N-acetyl-L-cysteine, NAC, 750 milligram, 750 milligram capsule a day. Methylene blue, 2 10 milligram capsules, 1 every other day. And nano EGCG, an extract from green tea, 1 250 milligram capsules, once or twice a day, with or without food. I'll just add before I continue that you've written, at least, I know you've even talked about nutrients in a number of the papers that you've written, Dr. Blaylock, and I'm aware of one specifically focused on the phytonutrients, and I'll put that in the description below so viewers can also have a look at that to get more detailed information on this. A few more that you added. One is magnesium, especially magnesium plus riboflavin 5-phosphate. And what is the significance of the 5-phosphate? Because I've noticed that attached to a number of the compounds that you've listed. What is the significance of that?
Yeah, in the biochemistry that we see in cells, they don't usually utilize certain vitamins as they're absorbed, like riboflavin. People take riboflavin, where your body has to convert it to riboflavin 5-phosphate. Then it's functional. It does what it's supposed to do. Same thing with pyridoxal 5-phosphate, and that's vitamin B6. And vitamin B6 has to be converted or it's just not functional. The problem is you get older, you have difficulty converting them. So people take their riboflavin and they're 65, 70 years old, they're not converting it very well. So you just go ahead and take the one that's completely converted, riboflavin 5-phosphate. And what they found is riboflavin phosphate is extremely effective in mitochondrial diseases. People's fatigue goes away, their muscle strength increases, their cognitive function increases. And you combine it with magnesium. Well, magnesium, most Americans are deficient in magnesium. And deficiency in magnesium will trigger inflammation. And so if you bring it back to normal, it inhibits inflammation. And in the brain, it stops excitotoxicity through one of the glutamate receptors. So it's very effective, very important.
And the last one on this list that you had is nanoastrographin, 1 capsule twice a day.
Yeah, it's shown to improve mitochondrial function, particularly in heart failure. The heart tends to work better, has more energy. Most of these things are boosting energy. Now, the nano EGCG also is bringing down the inflammation. And I found it plays a huge role in controlling inflammation. People just feel a lot better after they take an EGCG. Now, in a rare instance, CG can cause some liver damage or liver changes. And if they stop it, it returns to normal. I've never seen it. I've never seen anybody have a reaction to EGCG. But they even react to drinking green tea. So it's not a fact of it being nanosized, it's just they can't have it at all. And nobody's figured out what's happening to these people. Why are they so sensitive to EGCG?
Well, what kind of reaction would they have in drinking green tea that might tell them they should avoid EGCG?
Well, they usually get fatigue, and some of them turn orange, jaundice, and they go to the physician and they get blood tests, and their liver enzymes are elevated. So if he knows what he's talking about, tell them, don't drink green tea anymore, and it returns back to normal. But most of these things that you listed, like acetyl-L-carnitine, is just amazing, increasing energy. So if a person has an energy deficit, particularly as they get elderly, and they're sleeping all the time or just don't have energy to perform, you take acetyl-L-carnitine, and it really boosts the energy production, and it's been shown to improve mitochondrial function. Is the appearance of the mitochondria under a microscope. It looks a lot better. Biochemically, it's functioning a lot better. And what it's doing is stimulating the normal mechanism inside of the mitochondria. And it's not an abnormal molecule. You have acetyl-L-carnitine in your body. The acetyl part in your brain turns to acetylcholine, which is your main memory molecule. So it's doing two things at once. It's improving your memory and it's improving your energy level.
Powerful, powerful compound. I was interested to know what, because you've listed so many, over 20 different compounds here. So I put the question to you in an email. What would someone, say over 50, who may already be experiencing some symptoms related to neurodegeneration? Someone who might be having some memory deficit, experiencing brain fog. What regimen of these things, which of these things might they take in combination? Because they're not going to take 20 supplements, obviously. And so I'll just read off what you sent me, Dr. Blaylock, in terms of that, a kind of regimen for a hypothetical person looking to prevent or improve their mitochondrial function. And we'll have this come up on screen. Well, this will be in the description for people watching this live. Acetyl-L-carnitine, 2 500 milligram capsules a day in the morning. Resveratrol, either pterostilbene or nanoresveratrol. This is the compound that's associated with red wine, but you can probably experience it more healthily by taking it in supplement form. Nanocurcumin, 250 to 500 milligrams 3 times a day. Niacinamide, if I'm saying that correctly, 100 milligrams twice a day. Bicalin or
Biochemically.
1/2 a teaspoon twice a day dissolved in water. Hesperidin, 1 capsule twice a day. NAC, 700 milligrams twice a day. Vitamin C and B complex vitamins. Riboflavin, that includes riboflavin 5-phosphate, 50 milligrams twice to 3 times a day. And nano-EGCG, the green tea compound we were just talking about, 1 250 milligram capsule once to twice a day. Anything any notes you'd add to that in terms of taking those things, Dr. Blaylock?
It seems like a lot, but we've always said complex things take complex treatments. And most of these diseases are complexes. They're not one thing. You just don't take a supplement and correct that one thing. What we find in all neurodegenerative diseases, and cancer and various diseases affect humans, is they're multifactorial. A lot of things have gone wrong. It's not just mitochondria. It's accumulation of various toxins. It's increasing the ability to detoxify. And most of these things do them all. It's so different than a drug. You take a drug, it does one thing, and it has a lot of side effects. When you take plant extracts, it does a lot of things, and there's virtually no side effects. They've been used, most of these things have been used for thousands of years. It's not like some of these pharmaceutical drugs that's been used for a month or a year. And we see this long list of complications from it, and we're discovering complications. For instance, these proton pump inhibitors like Nexum, found out it causes dementia. Well, its mode of action is it inhibits acetylcholine, which your brain uses to make the memory molecule. So even with drugs that's been out there for a while, we're beginning to find out, wait a minute, there's side effects that are pretty serious, and they're irreversible by most standards.
So certainly advantages to taking the natural medicine path and trying these phytonutrients over the pharmaceutical options that might be out there. And again, something to consult your own doctor or healthcare provider about as well. Just lastly, Dr. Blaylock, I'm interested to know if someone is to start taking these, how long would it take, and what kind of effects might they start to see to tell them that these supplements are having an effect on improving their mitochondrial function?
Yeah, it's usually delayed, and this is the difference between drugs and pharmaceutical drugs and natural products. Is a pharmaceutical drug, it's almost immediate. Well, you have a joint hurt, you take non-steroidal anti-inflammatory drug, and it quits hurting. Well, we can do the same thing with natural supplements, but it may take a little while. It may take a week, may take 2 weeks. You may have to take it for a month or more. Gradually, it's doing a lot more than the pharmaceutical drug and without the complications. So a lot of people give up too early. These things are really helping, but they give up too early because they don't see this drastic change. Now, one of the exceptions is like acetylcarnitine. You'll see it the same day. It's a natural substance in your body. It's just you're increasing the amount, and so you'll see it pretty quick. Resveratrol, sometimes you can see it fairly quickly. Curcumin, you sometimes can see quite quickly. So it depends on the supplement, but don't give up too early. Sometimes it'll take.
So someone experiencing fatigue might see a sudden, fairly instantaneous return of energy taking something like L-carnitine or resveratrol.
Oh yeah, and nanocurcumin. The ECGC is very quick. So some of them are quite fast, just as good as any drug. Others are slower. And even the research has shown, well, some of them that reported no effect, another research used a larger number of people and found out, well, actually, if you increase the dose a little bit and extend it several months, it starts working. So it can take a while. And so you have to kind of readjust your brain. Well, I'm not going to take one capsule and suddenly I'm dancing in the street. You know, you're going to have to give it a little while to work.
Mm-hmm. Wonderful to speak to you again, Dr. Blaylock, and really appreciate the very detailed information about these specific supplements that can be used to improve mitochondrial function. I'll put the link to our previous interview, our previous live interview here on this channel, that looking at Alzheimer's disease and specific compounds that have been used that can be used to prevent Alzheimer's symptoms. The link to that will be in the description below. Also, the link to the paper by Dr. Blaylock that I mentioned. And wonderful to have you join us for this second live, looking at essential compounds for improving health, and hope that you'll join us here again soon. And thank you very much, Dr. Blaylock, for your insights.
Well, thank you very much. I appreciate it. It was an excellent interview. You asked some very good questions.
Thank you, and some brilliant answers. We'll see you here on Vital Signs on this channel here again soon. Thank you.
Thank you.